In today's episode, Maggie asks, would you use Chai'd analysis to discover relationships between multiple categorical predictor variables? For example, using Google Analytics dimensions like traffic channel, device type, country, landing page, etc., and group them according to their likelihood to convert. What else can be used for a similar analysis? So, Maggie knows her stuff when it comes to classical statistics. Chai'd, which stands for chi-square automated interaction detection analysis, is a classical statistics method for doing multiple outcome statistics. It is similar to decision trees, but what makes it different than decision trees is that at any given point when you're trying to split up data, it can have more than one split, whereas decision trees are always binary. They're always split. One part goes this way, one part goes this way. It's also the reason why it's so popular in classical statistics is because it creates a model that is very easy to interpret. A human being can look at a Chai'd analysis on paper and go, oh, okay, I understand what's going on here. Whereas when you look at something like, if you have a massive decision tree, it can be very hard to figure out, like, what exactly are we doing? This tree is, 200 layers deep and has 40 splits each way, and it is more like a tangled hedge than a tree. That said, it has fallen out of favor. The technique has fallen out of favor, really since more computational power became available in the 90s. Now, it's available. It's in tools like IBM Watson and IBM SPSS. It's available, and for those people who know what it is and know how to use it, it is still useful. And there are times, we've talked many times, there are times when a classical technique may be better than the state of the art, because the state of the art may be computationally intensive, harder to interpret, and only offer a couple of percentage points improvements over the classical method. This is especially true in things like time series forecasting. The classical methods are still on par with state of the art for the ability to predict. Chai'd is useful for data that is not in a normal distribution because it uses chi-squares for its splits, which is important because a lot of marketing data is not in a normal distribution, which means it doesn't look like a bell curve. Most marketing data looks like a power law curve, tall head, long tail. In fact, there have been marketing books titled The Long Tail. And as a result, it's not a normal distribution. And so a technique like Chai'd, or any technique that's non-parametric, is important for being able to work with marketing data. But Chai'd is not particularly good at prediction. And that's what a lot of marketers are trying to figure out, is not necessarily the relationships between variables, but what variables in combination predict the outcome we care about. So in Google Analytics, you may be looking at, I care about conversions, right? I care about goal completions. What are the variables and their interactions that predict a goal completion, so that I know I need to spend more money on mobile ad bids, or I need to spend less money on Facebook. That's the kind of information we want. And for that, Chai'd has fallen behind classification and regression trees, or CART techniques, especially because the newer techniques, because something like a random forest is still only 50 years old, not exactly new, and large-scale random forests are much more powerful for that type of prediction. And then even newer techniques that still fall in the family, but things like gradient boosting, stochastic gradient descent, extreme gradient boosting, and the state-of-the-art for the average machine learning professional who has access to the technology really are strong ensemble methods. Tools like IBM Watson Studio's AutoAI or H2O's AutoML are the best at doing this kind of analysis today, because they can do all the hyperparameter optimization, they can do all the feature engineering, or I should say the feature extraction, because they can't add any net new features. But most importantly, they can do all of the algorithm testing and selection for us and put together as a stacked ensemble of the best techniques, which may include Chai'd at some point in the stack, but then also have all the CART techniques above or below or in parallel to that. And that's what is the best in class today are the stacked ensemble techniques, where a machine looks at our data. H2O's AutoAI for AutoML, for example, takes the categorical predictor variables, does one hot encoding, turns them into they're still categorical but they're numerical, and then runs them through gradient boosting, GLM, GBM. It does neural networks, and then it says here's the combination of methods that work best for this data set without too much overfitting, because it does you specify doing like a 60-20-20 split. So from a hardcore data science and machine learning perspective, using these automated methods for classical statistical problems is the best choice today, because they can do 50 or 100 or 200 different tests on the data in order to give you the best combination of variables, deploy a model, and then have that model take in new data from the data source. Google Analytics is a great example. Once you build a model, you want to have data streaming into it, and then updating and retraining the model and tuning it so that you get accurate predictions about like what's happening with your data. If you need to be able to explain step by step what a model is doing to somebody, Shade is still a great choice, because you will incur some performance penalties, you will incur some accuracy penalties, but you will have a model that you can literally draw on a whiteboard and somebody can understand. If you need maximum performance, you need to use stacked ensemble methods. That's pretty much the way things go these days. Great question. Very, very technical question. So if you are new to stats and data science and machine learning, most of this episode was probably like, I don't know what's going on here. And that's okay. Just know that that technique selection is rapidly being handed over to machines because they're better at it. They can do more variations. It's like fundamentally what we're talking about. If you were baking cookies, a machine will go through and test bake every possible variation of the cookie with all the ingredients, and then test bake at every possible temperature of your oven and tell you this is the best combination of ingredients and the best combination of oven time and temperature to yield the best cookie you can get. And that's where machines really outshine humans today for any kind of prediction, just that rapid tuning. So great question, Maggie. Glad to see that there are folks out there who are working in this realm as well, based on the content of your questions. Always fun. As always, please leave your comments below, and please subscribe to the YouTube channel and to the newsletter. I'll talk to you soon.
Want help solving your company's data analytics and digital marketing problems? Visit trustinsights.ai today and let us know how we can help you.